Okay, so before we start Simplex, I want to introduce you to some of the few terminologies. In LP. Okay. So the first one that we have is solution space. So solution space is nothing but, please remember, the region which is defined only by the constraint set. Okay. So the region which is defined by only the constraint set of the LP is your solution space. The second is your feasible solution space. So this is the region which is defined by the constraint sets as well as the non-negativity restrictions of the LP. Okay. Okay. Third is solution to LP. So what I mean by this is any set of values of xj, okay, which satisfy the constraint set. Is termed as a solution to the LP model. Okay, please remember, solution to LP is kind of linked to solution space only. Okay, it is only constraint set. Similarly, solution to the LP means any solution which satisfies only the constraint set. Same goes for feasible solution. So feasible solution I won't write here. It is nothing but any set of values of xj which satisfy the constraint set as well as the non-negativity restrictions. Okay, that is termed as a feasible solution to the LP model. And finally, we have the optimal solution. So optimal solution is any set of values of xj that satisfy the constraint set, the non-negativity restrictions, as well as optimizes the objective function. Okay, that is maximize or minimize. That is termed as an optimal solution to the LP model. Clear? Okay. Next we have binding, or we call them active constraints. So a constraint is binding if the left-hand side and the right-hand side of the constraint are equal. Okay. When you are basically substituting the optimal values of your decision variables into the constraint, if you find that your left-hand side is equal to the right-hand side of the constraint, then that is a binding or an active constraint. Okay. So another thing we also say, I guess you guys know, slack or surplus. That is basically 0 for these kind of constraints. Okay. Similarly, next thing we have is non-binding or inactive constraint. So similarly, when you are substituting the optimal values of your decision variables into the constraint, your constraint is non-binding if the left-hand side and the right-hand side are not equal. Okay. So this non-binding constraint will always have some kind of slack or surplus at the optimum solution. Okay. So up to a certain level, this is just for you to note, if you relax this constraint, the optimal solution is unaffected. Okay. Up to a certain level only. We will read all this when we delve further into sensitivity analysis and everything. But if you relax this constraint, the optimal solution is unaffected. But the solution space gets affected. Okay. So you will understand more when we discuss this in details. Okay. Okay, redundant constraint, now you all know. Kalal Karthik is joining, I guess, for the first time. Have you referred to the previous videos? Hello?
But I have basic understanding of LP, so I can
Okay.
manage from here.
Okay, cool. So a redundant constraint is a constraint which does not affect the feasible region at all. As I was saying in the last class, in general, all the redundant constraints can be removed from an LP model, okay, without affecting the optimal solution. However, if you have to resolve the LP model later, changes in some of the data might change a previously redundant constraint into a non-redundant constraint. So I would rather suggest it is better that you keep all the constraints rather than trying to remove it or anything. Okay. So this was all about the terminologies. Next thing we'll read is about a standard form of an LP. So what is a standard form? So a linear programming model in which all your variables are non-negative, all constraints are equalities, and right-hand side value of a constraint is positive. Okay, that is said to be in a standard form. Okay, so let's say you have inequalities constraints, right? Then how will you make it into equalities? You will basically add slack variables to less than equal to constraints and subtract surplus variables from greater than equal to constraints. So what I mean is, for example, let's say you have a constraint like this, x plus 3y greater than equal to 2. If you have to make it equal, so x plus 3y minus e is equal to 2, right? Similarly, if let's say you have x plus 3y, you basically add a slack variable. So this is a slack variable, this is your surplus variable. Okay. Now, slack and surplus variables, they represent the difference between your left-hand side and right-hand side of the constraints, right? So I told you what is a slack and what is a surplus variable. Now, the basic requirements you understood, right? All decision variables have to be positive, right-hand side of the constraints have to be positive, and all constraints have to be linear and equality type. So, let's say you have to convert this LP into a standard form.
So I have a query here.
Right.
So yeah, so can't I yeah
Yeah, tell me, I can't hear you.
so yeah so can't I write this first inequality x plus 3y is greater than or equals to 2s
Hmm.
minus n minus 3y is less than or equals to say minus 2, and then I mean, so is this possible that I multiply the left hand side and the RHS of the inequality by minus. And so say I mean in this case, say if instead of the 2 here in the right hand side, say if it
Hmm.
is minus 2. So
Hmm.
the given inequalities of the form, say x plus 3y is greater than or equals to say minus 2. So
Hmm.
it's possible that I multiply both the sides by minus 1, and still then instead of using the surplus, I use a slack variable.
Your right-hand side has to be positive.
So oh, that's why I said that instead of 2 in the inequality, let us assume that it is minus 2.
Then you have to make it into a positive sign.
So then if
Only
I
then you can have a simplex, right? Because what does your simplex say? Your simplex will ultimately say that all variables are non-negative, okay? These right-hand side values will go into your final column of the simplex table, and then you cannot do anything about it if you have a negative sign. So you always have to convert it into a positive sign. This is the first step of
so what
first step before jumping into simplex. Yeah.
so now my query is that what if the given inequalities of the form x plus 3y is greater than or equals to minus 2? So how to
Okay.
handle it? Yeah.
Okay. That's it.
Yes. Okay. All right. Thanks.
Okay. Yeah. And x1, x2 is greater than equal to 0. Okay. Now, so non-standard form indicates you have a greater than equal to sign here. Okay. Then constraint with the right hand side value as negative you have. And greater than equal to or less than equal to sign, you can say. And decision variables may be non-positive or may be unrestricted in sign. So luckily here, you have all the decision variables as positive. Okay. So how do we convert this? So we can write this as minimize z equal to 2x1 minus 4x2 subject to 3x1 plus x2 minus e1 is equal to 10. 2x1 minus x2 is equal to 4. x1 plus s3 is equal to 8, where e1 is your surplus variable, s3 is your slack variable. Now, just one thing that I want you to know. See, you are introducing E1 and S3, right? I'm just doing it. Why E1 and S3 I wrote is E1 for corresponding to the constraint number. Okay. Now, if you see this E1 and S3 do not have any participation in the objective function. So I can write it as plus 0 into E1 plus 0 into S3. Now, always remember, if the slack variable value is 0, then your corresponding constraint is a binding one. Okay, same goes for if your surplus variable is 0. So that is how you understand from the Lindo or Lingo output. Okay, I will teach you how to use Lingo. Not in today's class. It's a very simple thing, I think, which I was referring to in the very first class. So there, once you see what are your slack and surplus variables, if they are 0, you can instantly identify that, okay, this is my binding constraint. Okay. Now, okay, some few terminologies you need to know. Basic and non-basic variable. Okay. So let's say we have a system of linear equations, right? A11 x1 plus A12 x2 plus A1 and xn is equal to B1. Similarly, A21 x1 plus like this. Let's say you have till AM1 x1 M2 x2 Mn xn equal to Bn. Okay. So basic variable means, please remember this definition, it's very important. For any linear system, a variable that appears with a coefficient of 1 in a single equation. Okay, a variable that appears with a coefficient of 1 in a single equation and a coefficient of 0 in all the other equations is called a basic variable. Okay. So what is a non-basic variable? Non-basic variable is any variable that is not a basic variable. Okay. So this is a very important definition that you should always remember. Another way you can define this as a variable which contributes to the objective function value.
So what this coefficient of 1 in a single equation means?
For example, let's say here, okay, take S3. S3 has a coefficient of 1, right? In only a single equation, but it doesn't appear in any other equations. So you can say I can consider S3 as a basic variable.
Like x1 here has the coefficient 1, but then x1 is appearing in the other equations as well. So this is what
Exactly. So it is not a basic variable. Okay.
Oh,
As of now.
yes.
Huh.
And even,
Because
even is also a basic variable, isn't it?
no, E1 has -1,
Oh, I see. Yes.
right? So this is the thing. So what you have to understand is basic variable, say you arrive at the optimal solution gradually. So ultimately you can see that if you see the original model, you have x1 and x2 here. Ultimately, x1 and x2 will be having the value. So x1 and x2 will enter into the basis and become basic variables at some iteration. But initially, when you have to solve this model, you will be considering only S3 as well as another variable as well. When I introduce you to Simplex, I will tell you. Okay. Okay. So just to wrap it up, a few things that you should know. So what are the 4 kinds of solutions that we have currently learned, which you can, get from an LP solution?
So what did you write here? Of the value of objective function value contribution means what? Which is not contributing or contributing?
Contributing. Any variable which contributes to the objective function value is your basic variable. Okay. Which is
But
why
then,
I'm saying that sometime later in some iteration, x1 and x2 will enter the basis because see, x1 and x2 are contributing.
oh, I see. Yes.
Currently, S3 is not contributing, but it's okay. See, this is just another definition that you can use. Okay, but not really a hard and fast rule. The hard and fast rule that you have to follow for understanding your basic variable is this: coefficient of 1 in a single equation and 0 in all. Okay, so anyway, so one solution that we did not discuss in the last class was degeneracy or degenerate solution. Okay, so, so what is a degenerate solution? Any solution is said to be degenerate for an LP model if one or more of the basic variable in the basic feasible solution has a value of 0. Okay. So for example, let's say you have some m constraints and n variables. Okay. And you should have m plus n basic variables. But some of the variables in these m plus n, either one or more, do not have a value only. They have a value of 0. That means you cannot do anything about the solution. So that is known as a degenerate solution. Okay. And to wrap it up, we discussed what is a unique optimal solution.
And
So
probably
yeah,
formally define this term BFS, basic feasibility solution.
basic feasible solution. See, I have already discussed what is a feasible solution
Yes,
here.
but
So
not the
you
basic.
know feasible solution is constraint set plus non-negative restrictions.
Yes.
Basic means something which has entered your basis. Okay. This is how you start defining the basis. Okay. Basis is nothing but the basic variables only. Okay. But basis means a solution space having those basic variables. So basic feasible solution, not even optimal solution. I'm saying in the basic feasible solution. Okay. The initial values only when you start and you're solving with each and every iteration of the simplex. At the final solution or at the final iteration, let's say you see that, okay, one or more than that, 2, 3 variables have completely lost their value. So it's very obvious, right? You would not be getting any solution to this linear system of equations. There is no point. Now, there are ways to handle degeneracy, but usually it is like a lost case. So we call it a degenerate solution. We cannot do anything about it.
Maybe this
Okay.
point is not clear, not that clear. Initially, what is there in the BFS? Because initially, one or
See,
more.
when I teach you simplex, you will understand it. Okay. As of now, I'm just giving you a brief overview as well as the terminologies because these will be coming up over and over again. So
Okay.
later on, you should not get confused. Okay. So I will tell you how do you arrive at a basic feasible solution and everything as we move. Okay. Okay. So graphically, if you have to recognize a unique optimal solution, how do you do it? It basically means that your objective function will touch only one of the extreme points of the feasible region. Only one of the extreme points, okay? But what about multiple optimal solution? Multiple optimal solution is objective function is parallel to one of the binding constraints. That means your objective function will touch or intersect an entire line segment corresponding to a binding constraint before leaving out of the feasible region. Okay. What about infeasible? So graphically, we recognize the infeasibility as the case where there is no feasible region. And what do you mean by a no feasible region? That is, there is no solution or a set of values of some xj which satisfies all the constraint set and the non-negativity restrictions simultaneously. Okay. And finally, we have an unbounded solution. So graphically, this means your feasible region will extend to infinity in a direction in which the objective function increases. In real-world optimization problems, unboundedness will never occur because it is not possible to reduce costs to minus infinity or to increase profits to plus infinity. Okay. Now, so these were some of the insights from your graphical solution procedure. Now we will be studying or starting with algebraic solution procedure, which is your simplex method. So before I start, anyone has a background of simplex? Anyone who knows what is simplex method?
Ma'am, we have learned about it in our undergraduate, but it has been some time, so I'm not.
Okay, fine. I will brush it up, not a problem. So there are a few steps, okay, of a simplex problem, of a simplex method. So the first step, as I said, is you can write it down also as I say. First step is that you have to convert the LP to a standard form. And we already know what is a standard form now. Okay. Second, obtain an initial basic feasible solution, if possible, from the standard form. Okay. So if there is no basic variable with respect to every constraint equation, okay. For example, let's say here when you see, right, here you don't have a basic variable because as I said, none of these variables have a coefficient of 1 in one equation and 0 in all the other equations. So just note it down. If there is no basic variable with respect to every constraint equation of the standard form of LP, then introduce artificial variable, or we call it artificially a basic variable to get a basic feasible solution. Okay. How we do it, I'll tell you. Then set up the initial simplex tableau. Determine whether the current BFS is optimal. Okay. If the BFS is not optimal, okay, then determine which non-basic variable should become a basic variable. Okay, which non-basic variable should become a basic variable and which basic variable should become a non-basic variable. Okay, to find a new BFS with better objective function value. Okay. So you have to keep doing this with every iterations to arrive at the better objective function value. Okay.
What
So
is there
standard,
in the
yeah,
form?
tell me.
Yeah, what is there in the standard form?
This is
mean,
the standard form, right?
What should be the format of the inequalities then?
Huh?
What should be the form of the inequalities in a standard form? I mean, whether.
Equalities, they should become equality constraints, right?
Oh, I see.
Yeah, I already wrote.
Yes.
Okay. So, I was expecting a few questions, but chalo, I will ask you only, okay? So now you know to get a standard form for getting equality constraint, okay, you have to introduce an excess variable or a surplus variable in left-hand side of the constraint with greater than equal to sign, okay? So you introduce a surplus variable. For less than equal to constraints, you introduce a slack variable. Okay. If your right-hand side value is negative, you multiply with -1. Okay, to make the right-hand side value positive. Okay. But let's say your decision variable x1 is less than 0. How will you convert this? What transformation will you do?
So, I mean, replace x1 by, say, some other variable, say -y1.
Yeah, absolutely. So let's say you can write x1 equal to -y1 and y1 greater than equal to 0. Okay. So this is when less than equal to 0 because all the variables have to be non-negative in sign as well. Okay. What if your decision variable is unrestricted in sign? That is, it can be less than 0 or equal to 0 or greater than equal to 0. Then
What did you say? Unrestricted. So what this URS stands for?
URS means unrestricted in sign.
In sign means what?
Nature of the sign.
I cannot understand this. Nature in the
That
sign
means x2 can be less than equal to 0 or
Mhm.
equal to 0 or greater than equal to 0.
Oh, I see.
Okay, it can have any sign. So what is the transformation that you will be doing? Okay, in this case, what you can do is you can write x2 is y2 minus y3 and y2, y3 is greater than equal to 0. That's it. Okay, so let's say if your y2 is 5, y3 is 6, x2 is -1. y2 can be 6, y3 can be 5, 1, or both can be 0. Okay, so this is the simple transformation that you have to do. Okay, now moving on to our previous example. Okay, we are sticking to this example. Okay, so I will just rewrite the LP in the standard form so that I do not forget it. Okay, I think.
So in this example you gave, say y2 is equal to 5 and y3 is equal to 6. So then x2 is -1. And its value is negative, but then the imposed restriction is that all the variables should be non-negative, isn't it?
Yes, 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 ultimately. Okay.
So is it correct or incorrect?
What is correct or incorrect?
So if the value of y2 is 5 and y3 is 6,
Huh?
if we carry out such a transformation, like so this x2 is equal to y2 minus y3,
Hmm.
and so if y2 is 5 and y3 is 6, so x2 becomes minus 1.
Right.
So, but then minus 1 is not allowed, isn't it, or allowed? Because
Nobody said it is written, na? I told, na? If x2 is written unrestricted in sign, then you do this transformation to convert it into your standard form.
oh, I see. Yeah.
Yeah. Okay. Okay. So, the standard form which we had from our previous example was 2x1 minus 4x2 plus 0 into E1 plus 0 into S3, okay, subject to 3x1 plus x2 minus E1 is equal to 10, 2x1 minus x2 is equal to 4, and x1 plus s3 is equal to 8. And E1, S3, X1, X2 greater than equal to 0. Okay. Now to get a basic feasible solution in the standard form of an LP, okay, each constraint, please remember, each constraint should have a basic variable. This is very important. Now, you can see only the third constraint has a basic variable. Rest all do not have. So in order to have basic variables for the other two constraints, we will be artificially introducing basic variables for constraints 1 and 2, that is A1 and A2. And how do we do it? Very simple. Okay. So now this will become, forget about this as of now, subject to 3x1 plus x2 minus E1 plus A1 is equal to 10. 2x1 minus x2 plus A2 is equal to 4. This remains the same because it has a basic variable, and my objective function becomes 2x1 minus 4x2 plus 0 into E1 plus 0 into S3. Plus, since this is an artificial variable, okay, you give a coefficient of m, ma1, okay. So, always remember, okay, these are artificially two basic variables that you have introduced in the model. So these have to be eliminated, okay. Let's say m is a very high number. Because this is a minimization problem, we are writing m is a very high number. Okay. Usually if it is a high number, A1 and A2 will drastically reduce. So, since these are what I said, artificially two basic variables you are introducing, these should be eliminated in the final iteration or solution. And in order to eliminate these artificial variables in your final solution, you have to penalize their contribution appropriately in the objective function. Okay. So for the minimization problem here, we are assuming a maximum positive contribution, that is MA1 and MA2 for every unit of this artificial variable in the objective function. So M is a very, very high number. Okay. But had this been a maximization problem, okay, so I'll just write it. For a minimization problem, we assume maximum positive contribution. For these artificial variables. Okay. And for a maximization problem, we assume maximum negative contribution. So we would have written in that case minus MA1 and minus MA2 for every unit of artificial variable. Okay. And here, as for the existing problem, you will have x1, x2, E1, S3, A1 and A2 greater than equal to 0. M very high positive number. Okay. Anyone has any doubts? This is clear, right?
Yes.
Okay, okay. So now what we do? We have already set up the initial table. Okay. So what are your basic variables now? Can anyone tell me?
So basic variables now are A1, A2, and then S3.
Absolutely right. Okay. So the initial basic variables that you have are A1, A2, and S3. So your step 1 and 2 is done. Okay. I cannot see the teams this. Okay. So let's say I assume a value of M as 1000. Okay. Current basic variables are A1 and A2, S3. What are the current non-basic variables?
The remaining ones X1, X2, and X1 and X2, X1, X2, and E1.
Yes, absolutely. That because a lot of times, what happens is, like people do not account for those basic variables, but you have to. Okay. Now, how will your simplex table look like? Okay. One thing which I want to remind you is the simplex method, which I am going to teach here in this course. It's very easy to understand. Okay. Usually, if you go through the books like Winston, it's the same thing, but slightly they have changed their notations and everything. Okay. So it might slightly look complicated to you. So please follow along. Okay. So I will draw a table, but before that, I'll first write down the columns. So this is my basis XB. Okay. Where, what are my basic variables? A1, A2, and S3. Okay. And here I will have the coefficients, CB or CJ. So here I have X1, X2, E1, A1, A2, S3. Okay. On the top, you have all the variables. But here you have only the basic variables. Okay. So this is initially my table. And this is your right hand side.
What is CB, CJ?
Nothing. These are like coefficients. Okay, I will tell you what is it. So what are the coefficients? For A1, I assumed a value of M as 1000, right? And S3 0 in your objective function. Okay. So these values you put here. What about X1, X2? That would be 2 minus 4. E1 is again 0, 1000, 1000, 0. Got it?
Yes.
Now, what are your right hand side? See, that is why I was saying that you have to have right hand side values positive. 10, 4, 8. Right? 10, 4, and 8. Okay. How do you fill up the rest of the table? These are nothing but your coefficients in the constraint. So, you have 3x1 plus x2 minus e1 plus a1, 2x1 minus x2 plus a2, x1 plus s3. Okay, got it? Now, before I tell you there are two more rows that you have to add here. Okay. One is Cj, another is Cj minus Hj. Now, what are these? Okay. So, the only way to change the current basic feasible solution is to do what? To increase the value of a non-basic variable, right? So you need to check the net effect. Net effect, or we call it the reduced cost of the objective function. Okay. So what is reduced cost? Reduced cost or net effect, that is Cj minus Zj, is nothing but the change in the objective function for a unit increase in each of the non-basic variables. This is a very, very important definition.
So
And how do we, yeah.
actually, this point is not clear when you said that the only way is to increase the value of the non-basic variable. I mean,
Right.
so
Because currently your basic variables are not contributing anything. So your goal would be that out of these existing non-basic variables, something has to enter the basis. And for something to be entering the basis, that means you're basically increasing their values.
yes.
Okay, so that is why I said the only way to currently bring a change in your basic feasible solution is to increase the value of a non-basic variable.
Right.
So now these net effects consist of two effects. One is Cj, which we also call as the direct effect. And another one is your Zj, which we also call as the indirect effect. Okay. Now, what is Cj? And how do you calculate Cj? So Cj is nothing but the direct effect of increasing the value of a non-basic variable. That is, let's say x1 or x2 or e1, one at a time. One at a time from 0 to 1 in order to improve the objective function by its respective Cj. That is the contributing value, 2 or -4 or 0. Okay. So first things first, that is your, in general, an increase of the value of a non-basic variable from 0 to 1. That is, what I mean is your non-basic variable will become a basic variable such that one of the existing basic variables decreases from a current positive value to 0. That is, here only I wrote, no, somewhere here, if I remember. E1, yeah. So if not, one non-basic variable will become your basic, and one basic variable has to become your non-basic variable. Only then, I mean, it has to leave a space for one of these variables to enter your basis. So that is what I mean by this. Okay. So in our notation, oh, sorry. So in our notation, we won't be calculating Cj. First thing, because Cj is already there, right? So this is where I made a mistake. We calculate Zj. That is the indirect effect. Are you getting my point?
Yes.
And how? Okay. And how do we calculate Zj? So simple. See, in the first column, you have 1000 into 3 plus 1000 into 2 plus 0 into 1. So that will become 5000. Similarly, 1000 into 1 minus 1 into 1000, 0. Minus 1000, 1000, 1000, 0. As well as for the right hand side also, you will do the same thing. So 10,000 plus 4,000, 14,000. Okay. What is Cj minus Zj? 2 minus 5,000 minus 4998. Then minus 4. Then 0 minus of minus 1000, 1000. 0, 0, 0. Okay, here nothing. So please remember, this is your first iteration of your simplex table. The definition of the net effect is the rate of change of objective function for a unit increase in the non-basic variable. Okay. And according to the concept of Cj minus Zj, now here, if you see, I have to target one non-basic variable to enter the basis.
So actually,
Which one is improving the objective function value very fast compared to all the other non-basic variables? Can you tell me just with seeing the signs?
so the meaning, the intuition behind multiplying
Yeah.
this Cj and with the coefficient of x1 to get the value of Gj is not clear. I mean, what this 5000 is, what this 5000 represents.
What this?
So, I mean, what is being represented by this value 5000? It's true that probably we might have computed this value by multiplying 1000 with 3 and then 1000 with 2 and then 1. It's true, the calculation is like this probably, but then what is being represented by this value Zg?
So I already told you what is an indirect effect. What I mean by an indirect effect. Direct effect mein you can see that, okay, you are simply basically taking the coefficients and you are basically subtracting them. But what about an indirect effect? What did you understand?
So, I mean, actually the meaning of this term indirect effect is not clear. Why so? Because
Okay, indirect effect is nothing but when your non-basic variable, okay, enters the basis. So it directly affects the value of the objective function, right? Based on its coefficient. This is clear?
yes.
But the
Yes.
change in that objective function value, okay, that you have is not just due to the direct impact of the entering variable. It also has an indirect effect because the entering variable will in turn affect the values of all other basic variables in the solution.
Right.
Right? So, in order to compute that effect, what Danzig proposed was we multiply all these coefficients of the current existing basic variables and then combine it with the coefficients. So that is why for combining, see, in a lot of places you can have Zj minus Cj also. That is why I said in books you will have different notations. Okay, either you do Zj minus Cj or Cj minus Zj. But you combine the effect. So you have one direct effect, but in order to arrive at the net effect, you basically subtract the indirect effect.
I
So
see.
this is how they compute the indirect effect. So only the coefficients of the entering variable won't be taken into consideration. You also have to account for the fact that there are some existing basic variables which will also be impacted when a new variable enters the basis.
Right. So
Right?
does this mean that when I make a unit change in
Mhm.
the, so so what's the meaning of the 4 minus 4998 here then?
So you basically have to remember the meaning of this reduced cost, that for every 1 unit increase in the non-basic variable, okay, so let's say here, according to this concept, you see it's minus 4998. So that means x1 will improve the objective function value very fast, 4998 times compared to the other non-basic variables. That is what is meant by the definition of this.
And moreover, this value is in minus, and the problem is of the
Problem is
minimization.
a minimization. Exactly.
So,
Right?
so
So
it
you
is.
will try to identify the greatest number. Now, the question which arises is, okay, you have understood that which will be becoming a basic variable. But that means one of the basic variables, that is either A1 or A2 or S3, that should become a non-basic variable. Right? So which one? Which one will become a non-basic variable? So in order to do that, okay, I will just erase this. I hope that you have taken down the definition.
So, but then why is this necessary that if I'm including one non-basic into the basis, then one variable needs to be excluded? I mean, can't I keep
Because
both?
you can have only 3 basic variables, right? How can you add something else whose coefficients also you don't have?
And who told me this thing that I can only have 3 basic variables? Just because initially I was having the 3 variables.
Whatever initially you have, let's say you have 4 basic variables, 4 constraints, then you will have 4 variables only. However you set it up initially remains the same till the end.
Oh, I see. So if I have been
Okay.
given say 10 number of the inequalities, I mean 10 number of the constraints, so
If,
then
yes.
oh,
Because it's very obvious, right? 3 constraints, 3 variables. 10
yeah,
constraints, 10 variables,
right,
right?
yes.
Okay. Now, in order to identify that which variable becomes your basic one, what we do? We take something known as the ratio. Now, you have understood that, okay, I am basically sorry. You have understood that I am basically considering x1 here, right? So, what you will do is, you will do the ratio of 10 by 3, these coefficients, okay? 4 by 2 and 8 by 1. And identify the minimum positive ratio out of these. So here it is some 3.33, here it is some 2, and here it is some 8. So that means A2 will now become your non-basic variable because it has the corresponding minimum positive ratio. Now, why can you tell me why do we take only the minimum positive ratio? Why are we considering only minimum positive ratio here? Just
Possibly,
intuition.
yeah, possibly because I mean, how much A2 is contributing towards the value of the right hand side means towards fulfilling either the objective function or the constraints. Like
But
say,
why positive? And why minimum? Both of these questions I have.
so since I have to find the one who is least valuable among the A1, A2, and S3. So to find the least valuable thing, so here I can see that A1 is contributing how much? Say 1 unit of A1 is contributing say 3.33 thing in the right hand side. So A2 is the one who is contributing the least. So therefore we can and by assuming that all other things are zero, right? So out of
Okay,
A1, A2, and
close.
S3, yeah, in that sense.
Close. So close enough. So only positive ratios are considered because see, any kind of negative or zero ratio would mean that the corresponding basic variable would either remain unchanged or increase as the enter variable increases. So that would not lead to a feasible solution. First thing first, okay? Feasible means it has to be non-negative as well as satisfy the constraint set. But why minimum? Minimum is more because it is an indicator that which basic variable will reach 0 first as the entering variable is increased. Okay. So to ensure that no basic variable becomes negative during these pivot operations, to maintain feasibility, we select the minimum positive ratio. Okay. As simple as that. So now,
This point is not clear actually. So can you repeat this?
so just remember, in order to maintain the non-negativity of the basic variables. Okay, as simple as that, if I have to summarize. Because see, this is the minimum means this will reach 0 first. If let's say the other entering variable has to increase in the basis. So in order to simply account for that, we choose the minimum ratio. Positive to you anyway no, but we choose the minimum ratio. So now what do we do? So what we will try to do is, we will try to make So A2 is going to enter. So we will try to make these values as the same as this 0, 1, 0. And always remember during the pivot operations, simultaneously all the changes are going to take place. Okay. So oh, sorry. Don't have an, okay, maybe I'll construct it. So now what do we do? So in order for these pivot operations to take place, what is the first thing that you will do? So this is my, sorry. This is my second iteration. Okay. And now in the basis, I will have A1, X1, S3, Xj remains the same, X1, X2, E1, A1, A2, S3, right hand side. Okay. CB by CJ. 2 minus 4, 0, 1000, 1000, 0. Okay. Okay. A1 is 1000. Sorry. Need this table. A1 is 1000. X1 is 2. S3 is 0. Okay. Now, first thing first. So, in order to make these similar, what do we do here? What are the transformations that we do? If I have to make this 2 into 1, I basically do R2 by 2, right? So that this also becomes 1. So that means this is 1 minus 1 by 2. Simple Gaussian row elimination stuff. Okay, 0, 0, 1 by 2, 0 and 2. Also ensure that your right hand side values are also getting impacted. Now once this has become 1, I need to make this 0 as well as this 0. Okay, so what I can do now, R3 is R3 minus R2, right? So 1 minus 1, 0, 0 minus of minus half, half, 0, 0, minus 1 by 2, 1, and 8 minus 2, 6. Following? And now once this is also 0, now what I want to do, R1. So R1 currently has 3. So R1 minus 3, R2. So 3 minus 3, 0. 1 minus 3 into, so 1 plus 3 by 2, that is 5 by 2. Minus 1, 1, 0 minus 3 by 2, minus 3 by 2, 0, and 10 minus 6, 4. Got it? Everyone is clear?
Yes, but then why are we making the only one thing as 1 and all other things as zeros?
A2 has the value 0, 1, 0, no?
Yes.
So we are basically now your A2 becomes what?
So
A2 becomes a
A2 has
non-basic variable, right?
yes.
So we are just trying to do that here. We are just trying to take these values here as well as bring the simultaneous changes. Whatever is your basic variable, see x1 has entered the basis, that means it will have a value of 1 in one single equation and 0 in all the other, right? Simple.
That's true. That's true. But I mean, so but then why are we keeping the column values of x1 like say 0, 1, 0, wherein the a1 is 0 and s3 is 0 and only x1 remains as 1? I mean,
I'm not understanding your question.
the point here is that we want to remove a2 and we want to include x1 based on
Right,
certain parameters.
right.
And including the x1, we could have directly included x1 as the coefficient as 2, and we could have copied the values from the previous row, like the very first row of the first iteration. We could have written these values as 2 minus 4, 0, 1000, 1000, 0, like this. So why are we, why are we multiplying things? So why are we insisting so much that the coefficient of x1 remains as 1 in the column and all other values?
Because x1 is entering your basis in the second iteration.
So
How
it,
do you, wait, how did you understand that your values were basic here? By considering this side, you can see that it is 1, 1, 1. Whereas all the values are 0 in all the other equations. That is an indicator, right? That your A1, A2, S3 are the basic variables. Similarly, here also, if you see, you have 0, 0, 1. So S3 is still in the basis. A1 has 1, 0, 0. A1 is still in the basis. But now X1 has to be 0, 1, 0, no?
yes, now I
So in
understand.
order to make that 0, 1, 0, you are doing this Gaussian row eliminations.
Right.
Got it? Okay. So now, okay, I'll just make the table. So same thing, now you will be repeating. So once you have done this, same thing now, you will do Zj. and Cj minus Zj. So now you tell me, sir, what will be the values of Zj?
So Z here would be equals to 2 in the first
Right.
column, and minus 1 by 2 in the second column,
No,
and
no, 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 no. Zj would be 1000 into,
1000 into 0 plus 2
oh, right,
into
2,
plus
2,
1.
2. Yes. This one?
So Zj value in the first column is simple 2.
4998 by 2, right? Minus 1000, 1000, minus 3000 plus 2, minus 2998, 0, 4000 plus 4004. Okay. This is clear, right?
Yes, yes.
Okay. Cj minus Zj would be now 0. See, now it is 2 minus 2, 0. Okay. But now this one is minus 4, minus 8 minus 4998. So that is minus 5006 by 2, 1000, 0, 2000 minus of 4998 by 2, 0. Okay, so now you can very well understand which one do we have to consider, because this one has this value. So now we again do the same thing. Like here, we try to find out the ratio. So ratio would be now 4 divided by 5 by 2. So that is 8 by 5. Then you will have 2 divided by minus 1 by 2. So nothing. Okay, you cannot have a negative ratio, as I already said. Okay, so you simply leave it blank, and 6 divided by 1 by 2, 12. So which has the minimum positive ratio? This one. So now A1 you will be considering. Okay. Now A1 will leave the basis and X2 will enter. Okay. So now keeping this as the base table.
So while computing the ratio,
Yes.
why are we dividing, say, right hand side value 4 by 5 by 2? Is this correct, or we need to divide 4 by 1? Because the
I mean,
value of
why would I be teaching you incorrectly, right?
4 by 1, I guess. Because the 4 is the
4
value
by
of,
5 by 2. That is how it is done in Simplex, sir.
it's true, but then 4 is the value of the right hand side, and the coefficient
4
of
is the value of right hand side, yes.
and the value of the coefficient of A1 is 1.
A1?
Yes, because we are computing
No,
the ratio.
no, we are considering for the variables which will be entering the basis.
Oh, I see. Yes, right.
Okay, okay. Yeah. Now, okay, so this is your third iteration. Okay. So now in your third iteration, this is my basis, XB. X2 enters here, X2, X1, S3, XJ remains the same, CB by CJ, X1, X2, E1, A1, A2, S3, right hand side, 2 minus 4, 0, 1000, 1000, 0. And X2's value is minus 4. Okay. Not value, I mean coefficient is minus 4. 2, 0. So now what is happening here? Now you're basically trying to replicate X2 and A1, right? So X2 has to be 1 here. So what can you do? What will be the transformations? So here it is 5 by 2, right? So you can say R1 is R1 into 2 by 5.
Yes.
So that will become 0, 1, minus 2 by 5, 2 by 5, minus 3 by 5, 0, 8 by 5. Okay. Similarly, this is minus half and half. So you can simply do R2 is R2 minus R3. can also be done. So that will be 1 minus half plus half 0, 0, 0, half minus of minus half 1, 0 minus 1 minus 1. No, 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 no. I think I made a mistake. It cannot be independent of that. Otherwise, you will have a. Okay, I think I made a mistake. Yes. This can't be it. Okay. So now that this is 1, okay, what we can do is. Okay. So here we can do, here it is this half. So this has to be 0 now. What you can do is maybe R2. You can do R2 is
R2
currently minus plus R1 by 2, I guess. Can we do this? So then it will become,
yes, okay.
we can do, right? So then this will become 1 minus half plus half 0, 0 minus of minus 2 by 5 into half. So no, 0 plus minus 2 by 5. So this will be minus 1 by 5. This will be 0, 1 by 5. This would be half. This would be actually half minus 3 by 10. So that is 2, 5 minus 3. So this would also become 1 by 5. And this will become 0 plus 0, right? 0. And this will become 2 plus 8 by 10. 28 by 10, right? So this will become 14 by 5. Okay. And this will become R3 can be written as, so R3's value is currently half. So R3 minus R1 by 5, I guess. Because if I do this, half minus of 1 by 5 into, no, sorry. I got confused. This should be, I think, R1. Currently it is 1 only, right? So it should be half minus half, right? So this would be 0 minus 0, half minus half 0, 0 minus of minus half 1 by 5, 0 minus 1 by 2. So minus 1 by 5, minus half into minus 3 by 5. So minus half plus 3 by 10. Minus 1 by 5. This becomes 1 minus 1. And this becomes 6 minus half 8 by 5, right? So 6 5 is 30 minus 4, 26 by 5. Okay. Right. Got it? So, okay, any doubts anyone has?
It's clear.
It's clear, right? Okay. So you will have So you will have Zj. Zj values would be 2 minus 4, 8 by 5 minus 2 by 5, 6 by 5, minus 8 by 5 plus 2 by 5 minus 6 by 5, 12 by 5 plus 2 by 5, 14 by 5, 0. And this is minus 32 plus 26. No, minus 32 plus 14. How much is this? Minus 32 plus 28, sorry, minus 4 by 5. And you have again Cj minus Zj. So now you see this is 0, this is 0, this is minus 6 by 5. This is 1000 minus of minus 5000 plus 6. 5006 by 5. 5000 minus 14. 5000 minus 14 is 4986 by 5. 0. This is not needed. Okay. So same thing, same. Now you have this. I think this should be the final tableau that we are going to have. Okay. So likewise, you will have to compute the ratio. See, you can already see that this is the value. So sorry.
At this point, I have a doubt.
Yeah. Please tell me.
So what this, what this value 6 by 5 here represents in the column corresponding to the value E1, we have this value of Zj as 6 by 5.
Right.
What is being represented by this value?
So this is basically the direct effect that you have of the variable entering. That 1 unit you increase for you. Yeah.
So, so direct effect of which variable? Like in this table, if you refer to this table,
Direct impact of E1 entering the basis.
E1 entering the basic.
Yes. And S3 will also be leaving now. But
So
since you asked for Zj is basically the direct impact of this S3 leaving the basis and E1 entering.
So here, how do we get this value 655? By multiplying minus 4 into minus 2, 5. So, what's the intuition?
Sorry, Zj is the indirect effect, not the direct effect. Sorry.
Okay, so if Zj is the indirect effect,
Yes.
minus 4 by minus 2 by 5 represents
Yes.
what? What is being represented by this? That we are multiplying the coefficient of the
Yes.
x2 with the
Yes.
coefficient of the E1.
Yes.
So what it shows?
It basically means once your E1 enters the basis, how it is going to affect the current existing variables, that is x1 and x2.
And S3.
Okay.
And S3. Is this?
Yeah.
Okay. But still, somehow it is not that clear that we are multiplying minus 4 by minus 5. And minus 4 is the coefficient of x2, isn't it?
Yes. Yes.
So, what does it represent? That we are multiplying the coefficient of x2 with the value of the E1.
It is just a way to arrive at the kind of changes that your non-basic variable is now going to bring in once it enters the basis. Okay, how it is going to affect the other variables, by what coefficient, by what unit amount will it, how will it change the objective function value? See, the final thing that is your this wala line is basically meaning that the rate of change in objective function, right? For every unit increase in the non-basic variable. And how will you check the change in the objective function? By multiplying the coefficients, right?
Yes, so what's the meaning of multiplying the coefficient here is that moreover we are multiplying the coefficient of x2 with the coefficient of E1, the coefficient of x1 with the coefficient of E1. So, how does this capture the indirect effect?
What did you understand by the indirect effect as of now? According to you, what is your indirect effect in the simplex method?
Okay, so the indirect, how do I perceive it as?
Yeah.
So if I make 1 unit change in the value of the variable, say E1, and then how much, what would be the effective change in the value of the objective function as such? And since one is not alone in the pool, and there are other variables as such, like say x1 and x2 and s3 till now. So what we are doing that if I make a 1 unit change in the value of the E1, then how much effect I'll observe in the value of the final objective function that comprises of only the three variables found so far, x1,
Mm-hmm.
x2, and x3. So my query here is that, I mean, how did I reach to this value? I mean, why did I multiply the coefficient of x2 with the
You are
coefficient?
multiplying the coefficient because that is there in your original objective function, right? What is your objective function? It is nothing but 2x1 minus 4x2 plus this E1 plus S3. Okay. And in order to understand, once your E1 leaves the basis and let's say some other variable enters the basis, you have to calculate the indirect effect of introducing this variable. And how it is being done? It is being done by multiplying the coefficients of each of these variables in the column that you have by the corresponding coefficients in the objective function values. And then you subtract the resulting value from the corresponding objective function value. So this process will help you determine that which non-basic variable, when brought into the basis, would most improve the objective function. Either that is by increasing or decreasing as per your, what should I say? As per your requirement, whether it's a minimization or a maximization problem, right? Now, the non-basic variable with the most negative reduced cost in this maximization problem would be chosen as your entering variable. Okay, or vice versa. Okay, like that. But if you do not multiply the coefficients, how will you calculate the indirect effect that it has in the objective function, right? You can't. The change in the objective function, it's not just the direct effect of the entering variable. See, direct effect of the entering variable, direct may you already have Cj. Why Zj? Because it is also the combined effect of the change in the value of the variable which is exiting the basis and any other variables affected by the exchange. Why? Because the entering variable's coefficient that you have in the constraints will be non-zero, right? And this will cause changes in the values of the basic variables in those constraints. So these changes in turn affect the objective function. So for example, if you are increasing, let's say, some variable, non-basic variable x1, right, by 1 unit, and it directly increases the objective function by 5. But it also causes, let's say, another basic variable, let's say some x2, to decrease by 2. And decreasing x2 by 2 units will decrease the objective function by 3. So then the indirect effect of bringing this x1 into the basis is minus 3. So that is the overall effect that we are talking about.
Yes, yes, it's true. But then, why are we observing the effect as the multiplication, not by addition or not by division or by some other?
How can you add? In the objective function, all the coefficients are getting multiplied, right?
Yes, so like say, I mean, what this -4, 2, and 0 values here are? These are the coefficients in the objective function, right?
Right.
Yes. And then, so why are we? So what's the meaning of multiplying this -4 with the value -2 by 5? Because
See, if you see, wait, if you see this value of here in Zj, in the simplex table here, just a sec. What does this mean? This means 2x1 minus 4x2 plus currently 6 by 5 E1 minus 6 by 5 A1 plus 4. So that means this is the direct effect of bringing x1 that your value in the objective function has. But you cannot simply take these values, right? 6 by 5 minus 6 by 5, 14 by 5, which is why we are also computing the indirect effect. This is just in order to see that what is the direct effect of bringing the variable into the picture. So in the objective function, everything is a multiplied value. No, it is coefficients. Then why would you add or subtract anything? I mean, that is just logical. I mean,
yes,
more than this, I cannot give you an explanation, to be very honest. I mean, you can refer to any book, but I don't think any book has. I mean, it's a very common sense based intuition that you
yeah,
have.
probably I'm missing something. See, when I get the value of Zj as 2, it is well understood. Why so? Because if I refer the first column of x1, the value of x2 is 0, the value of x3 is 0, only the value of x1 is 1, and which makes sense. And similarly, if I get this value as -4, corresponding to the value, say x2, this also makes sense because only the value of x2 is 1, all other values are 0. Now when you come to the value even, so none of the value is 1, and we
So that is why you will be trying to Now again do the same thing, identify the positive ratio, get the corresponding variable, enter the basis, and then similarly your E1 will also have now 0, 0 and 1. Then in the fourth iteration, it will make more sense. That is what we are trying to do, right? With each and every iteration. I'm not saying that this is your final solution that you got.
Oh, yes, now I understood something. Yeah, thanks for clarifying this. Yeah, thanks.
Right? Okay,
Yeah.
so we are not stopping here. There is another iteration that has to be done. Then this will make more sense. But how you understand that even has to enter the, enter the basis, because you see you are having a negative value here. Again, in minimization problem, the reduced cost values all become positive. Had it been a maximization problem, in order to arrive at the optimal solution, your reduced cost value had to be negative. So now what we do is we do the same thing. We do the calculate the ratio. So that will be 8 by 5 by minus 2 by 5. Nothing. Here also nothing. But here it will be 26. So same thing. S3 would be now entering the, leaving the basis, and E1 would be entering. So in the fourth iteration that you have your basis XB, X2, X1, E1, Xj, CB by Cj, minus 4, 2, and E1 is currently 0, X1, X2, E1, A1, A2, S3, right hand side, 2 minus 4, 0, 1000, 1000, 0. Okay. And okay, now this one, what we can do is R3, 5 R3, right? So we can do 0, 0, 1, minus 1, minus 1, 1, oh, sorry, 5, 26, right? Now R2, R2 will become R2 minus 1 by 5 plus R3 by 5. Okay. So can you help me with the calculations? I mean, if I'm making a mistake, please point it out. So now here you will have 1 again. This would be 0 minus 1 by 5 plus 1 by 5, 0. 1 by 5 minus 1 by 5, 0. 1 by 5 minus 1 by 5, again 0. 0 plus 5 by 5, 1. 14 by 5 plus 26 by 5, that is 40 by 5, 8. Then you have 0 plus R3 by 5. So again 0, 1 minus 2 by 5 plus 1 by 5. No. Okay, sorry. For R3 also we'll have to do, no? So R3 will become R3 minus 2 by 5 plus, sorry, R1 plus 2 R3 by 5. Makes sense. 2, okay. 0, 1, 0. 2 by 5 minus 2 by 5, 0. Minus 3 by 5 minus 2 by 5, minus 5 by 5, minus 1. 0, okay. 0 plus 2 by 5. So 2, 8 by 5 plus 2 by 5 into 26. So that is 52 plus 8, 60 by 5, that is 12. Now your Zj, if I compute, that is how much? 2 minus 4, 0, 0, minus 4, and here it is minus 6. Here it is minus 32, I guess, minus 48 plus.
Can you check the value 1 in the second row? Is this correct? I mean, before 8, the value is 1. Instead of 1, it should be 1 by 5, isn't it? So incorrect. Because in the previous table, the value of x1 is 0, The
No,
coefficient
R2 plus R3 by 5. No, R3 is 5 here. No, 5 by 5. 1.
R3. Yes, yes, right, correct.
Then you have Cj minus Hj, which is now how much? 2 minus 2, 0, 0, 0, 1000, 996, and 6. So you have arrived at the optimal solution.
Optimal solution because all the values of Cj minus Jj are positive. This is the reason.
All are positive now. Yes.
So what does it mean that the values are positive, that the reduced cost is positive? So what does it mean?
The reduced cost values of all the non-basic variables now, right, are positive for a minimization problem. That means if they are positive, what is reduced cost? Reduced cost is rate of change in objective function for every unit increase in non-basic variable. So now if you are increasing them, they will just keep increasing, which doesn't make any sense for a minimization problem, right? So that is why for a minimization problem, if your reduced cost value of the non-basic variables become positive or zero, even in some cases it's zero also, that means you have arrived at the optimal solution. As long as it was minus, that means it could improve the objective function value. That is why we kept on doing it. Okay. So what are the optimal solutions? So now your basic variables are x1. Your final solution. Okay, I think I need to. I'll write it here only. Basic variables are x1 is 8, x2 is 12, e1 is 26, and in your non-basic variable, s3 is 0. Okay, artificial variables we do not really consider. So, how is the optimal solution? Degenerate or non-degenerate? How do you write it? Okay, I'll start the page. Okay. See, the optimal solution is non-degenerate. Why? Because the number of basic variables having strictly positive value is equal to number of constraints in the LP model. This is the first reason. Whether it is a unique or a multiple optimal solution, this is a unique optimal solution. Why? Because each of the non-basic variable has a reduced cost value as strictly positive. Divyanshu, are you there? I
Yes,
haven't.
ma'am.
Okay, you are getting, you have no doubts?
Ma'am, I have understood the basic, but I will revise it on my own because I had a call from
Okay,
workplace. That's why I was not able to.
no problem, no problem. Okay. And what are the binding constraints? Can you tell me? Goyal sir, can you try answering this question?
So binding constraints, wherein things are equal, is it?
Yes, yes.
Actually, the meaning of binding constraints was not that clear to me, except that when
Okay.
I the
Okay,
inequality.
fine, fine. I'll tell you. So if you plug in the values of x1 as 8 and x2 as 12, here,
Yes.
x1 as 8. What's happening? Why am I not able to write? And x2 as 12. Then how are you getting? 8 to just 16 minus 12, 4. That means second one is a binding constraint,
Yes.
right? And you don't even have to go and compute it. You can also see that S3 is 0. That means both the constraints 2 and 3 are binding.
2 and 3 are binding. Why so?
Yes. Because left hand side is equal to right hand side. 2 I showed you. Third one may S3 is 0.
Yes.
Right? Whereas the first constraint is non-binding. Why? Because there is a value of the excess variable, that is
E1 possibly. I mean,
E1. E1 is 26. Don't know why it's not able to write. Okay. Okay, I'll just take a 5-minute break and then we'll just wrap it up. How to, I mean, by 11, I think we'll wrap it up. That exactly by how are we computing this? I mean, how are we understanding whether it is a degenerate, non-degenerate, multiple, unique, unbounded, or infeasible solution from simplex method? Okay,
yes.
just 5 minutes break. Okay, I'll just wrap it up quickly. Can you hear me?
Yes.
Okay, fine. So, to talk about the insights from Simplex, for degenerate solution, how will you identify? So, if any one of the basic variable has a value of 0, okay, then it is a degenerate solution. So this happens when there is a tie in selecting a leaving variable. That is more than one variable. Okay, more than one variable will have same minimum positive ratio. Okay. Okay. Second is multiple optimal solution. So in multiple optimal solution, if any one of the non-basic variable has its reduced cost value as 0, then we have multiple optimal solution. Okay. Unique optimal solution you already know. Okay. Just the opposite of this. Okay. Either the reduced cost value of the non-basic variable is strictly positive or strictly negative, depending upon the nature of your problem. Third is we have the unbounded solution. Okay. So unbounded solution is if only one variable of the non-basic variable is there to become a basic variable, and at that stage, if we are not able to have any leaving variable. When does this happen? This happens if we are not able to get any positive ratio to identify a leaving variable. And last is we have the infeasible solution. So if your optimality condition is satisfied at an iteration, but the artificial variable is still in the basis. Okay. So I will request you to, what should I say, collate these points with that of how to identify in a graphical solution procedure. Okay, as well as do on hands as well, so that it becomes easier for you. Okay. And one small homework that I would like to give, or you guys tell me, because I can solve it for you, but it will be the same thing over and over again. And we have very few weeks left now. I mean, already the second week is over. So please solve this problem, okay? Because I'll be starting the sensitivity analysis in the next class. Please solve this as your homework problem. Now I'm giving you a max problem, okay? So max 32x1 plus 36x2 subject to x1 less than equal to 15, x2 less than equal to 25, 2x1 plus 4x2 less than equal to 90, 2x1 plus x2 less than equal to 48, and x1, x2 greater than equal to 0. Solve this using simplex. Can you do it in your homework?
Yes,
Yes.
yeah, I guess that here it is x1 comma x2, isn't it? And both are non-negative.
Both are non-negative, yes.
And all the constraints here are less than or equals to
Yes.
only select
Yes.
variable is required, and there is no surplus. Is it?
Yes. So if you want, okay, fine, I'll just give you the starting point as well. So if I convert this LP to a standard form, what will it become?
I'll have to add 1, 2, 3, 4. 4 select variables I need to add, and the coefficient of all the four select variables would be 0 in the objective function.
Yes.
And then we can draw the tableau and then keep on iterating the solution.
Yes. Exactly. So you can try it out, okay? So in case you have a problem, okay, fine. Since you already know, yes. So max 32x1 plus 36x2. Okay, first you convert it into a standard form, 0 into s1 S2, S3, S4. So everything is straightforward. Then you compute it, and then in the next class, we will discuss the solution you get. Okay. Now here, the reduced cost value, okay, if for each of the non-basic variable is negative, then only the problem has reached optimality. So just like in the previous example, we solved this, you have to do the same thing and tell me that what are the values of this. Fine?
Yes.
Yes.
Okay. Okay. So that's all for today's class. Thank you so much. And okay, maybe I will see if I can. I'll just send it to myself. Send it to myself. If I can. You can send me an email, okay? For those of you who need this PDF. And yeah, I'll share it with you, okay? As well as for the last class.
Thank you so
Okay.
much.
Yeah. Thank you so much. Yeah. Bye. Have a good day. See you in the next class.
Thank you.
Bye.
Thank you.